Alright guys, moving on with multiplying and dividing rational expressions. Okay, in the last couple of examples we have been simplifying down rational expressions. Okay, in this particular problem we need to multiply, okay, two rational expressions and then we have to go ahead and simplify it. So I like to be very thorough when I do this. I like to break this down into steps. You may not have to do this as you progress. However, in this video we'll try to take it slow and go through the steps. Alright? So when you have two rational expressions like this and you're multiplying them, what I like to do is I like to separate the coefficients from the variables. So looking at my numerator here, I'm just going to look at the coefficients here. I have a 2 and a 15. So if I do 2 times 15, what is that going to be? Well, that's going to be 30, right? So I'll have 30. And then I have my base of x, right? I have a base of x here and a base of x here. When we have the same base and we multiply, okay, well, what essentially are we doing? We're going to add, right? So when we have the same base and we multiply, we add the exponents. So in this case, it's going to be x to the 6th power. And then we have no other y, so it's going to remain y to the 5th. Okay, so there's my numerator. Now here comes my denominator. Again, I like to work the coefficients first. So 3 times 8 is going to be 24. And then again, base of x, I'm multiplying, so I add the exponents, it becomes x to the 5th. And I have no y, so the y just remains as y to the 2nd. Okay, and now all you have to do is simply go through this and do the operation. So again, work your coefficients first. 30 divided by 24, well, what is that going to become? Well, we can reduce that. Right? What can we reduce that to? If I have 30 over 24, what's going to go into both of these? Well, 6 will go into 30 5 times, and 6 will go into 24 4 times. Alright, so this will reduce to 5 over 4. So what I'm going to do here, make a little arrow, and I'm going to have 5 over 4, and I'm leaving room because I'm going to add to this. Moving on to my x variables. So we have division here, same base, and we're dividing. So it's the opposite of multiplication. When we have the same base and we multiply, we add exponents. When we have the same base and we divide, we subtract the exponents. So 6 minus 5 here is going to be 1, or just x to the 1st power, or just x. So x. Okay, and then looking here, again, same base, so I'm going to subtract 5 minus 2 here is going to be y to the 3rd power. So y to the 3rd power. Alright, let's move this 4 right to the middle. Alright, and this problem is now complete. Alright, so we have 5x y to the 3rd all over 4. Alright, so this would be your final answer. So I'm just cleaning up that 3. Alright, and that's it. Alright, let's try another example here. So let's look at another example. So again, your final answer is right here. Let's erase this, and let's try another. So a little bit different, but same concept with this one. We'll have x plus 2 all over 3x plus 12, okay, times, and we'll have x plus 4, and we'll have x squared minus 4. Okay, so again, we're multiplying two rational expressions here. So what you're going to want to do here is you want to try to factor, if you can, because remember, we want to try to cancel out top and bottom. Right? So this problem's a little bit different than the previous. All right. So what I'm going to do, I'm actually just going to multiply this across and write it as 1. So let's just go ahead and do that. If I do x plus 2 times x plus 4, I'll have x plus 2 and then x plus 4, alright? Looking here, we'll just rewrite this as 3x plus 2 times, right, x squared minus 4. So if I look at my numerator here, there's not too much I can factor there. It's already factored, right? I can't do anything else there. But if I look on the bottom, on the denominator, right, there's some more I can do here. So let me go ahead and move this over. So I'll rewrite the top as x plus 2 and then x plus 4 all over. Now let's see what we can factor here on the bottom. Okay, let's see what we can factor on the bottom. So what can I pull out of this first factor here? What do they both have in common? Well, it looks like I can pull out a 3, right? And if I pull out a 3, I'll have x plus 4, right? And then look at this. This is a difference of 2 squares. So I can write this as x plus 2 and then x minus 2. Okay? So I got it completely factored on the bottom, and now I can go ahead and cancel out similar factors that occur on both the top and the bottom. So let's do that. What cancels out here? Well, x plus 2, x plus 2, x plus 4, and x plus 4. So what are you going to be left with? Well, notice how everything canceled on the top. All right. Don't be confused by that. You're still going to have a 1 on the top. So you still have a 1 on the top. And then you just have 3 times x minus 2. Okay, and this here would be your final answer. So we'll have 1 over 3 times x minus 2. Okay, and that is it.